Dear colleagues, good afternoon. My name is Dmitry Denisuk. I am PhD student at Malaysia National University, Department of Computer Engineering and Information System. I present the result of research of the topic software implant detection system using decoys. This topic is very important today as cyber threats are become more complex and hard to detect. Uh, their goal outward is create a system find hidden cyber threat and using steganography send malicious command. Uh, Today I talk about motivation, the search and analyze exist approach. Next, for, from, formulation of the goal and objectives, the description of the architecture, preference, presentation of experiments, uh, practical approach, and conclusion. Uh, the number of use of internet resource is combined every day with have right to a new type of cyber attacks. One of the types of attacks is software implant, which the closed by steganography. Unlike connection attack, a software implants a patch of result software and cannot be detection antivirus and simulation classic method. Uh, uh, the aim of the research is development system of the detection malware. The use the steganography image to hide and control the system. To achieve this goal, the following tasks were set. First, analysis of the exist steganography and malware detection method. Developing a detection system architecture that combines honeypot and machine learning technology, creating training quality and recurrent recurrent neural network models for detection steganography and anomalous behavior. Conduction experiments study to the events the effectivity of the proposed system. The architecture is proposed system includes serialized modules. The first module is image upload interface when a user or potential attacks can upload your file. Next, image analyze module. This check image for steganography using CNN convolution neural network. If steganography is detected, the system activity observer models will monitor the activity associated with this image. To analyze the behavior of system result recurrent neural network with long short temp memory (LCTM) is used because he which calibrate of detection move and anomal patterns. Using CNN is the text steganography. CNN is used in the study because it is capable of the activity process and analyze image, highlight features and patterns. The many include the present hidden data. After CNN modules detect possible steganography, the system process of monitor activity social is image. The observer modules collects details information about process, the interface interact the file type of open, read, write, execute, system source uses, network connect status, uh, status. This allows you get complex bytes the system behave and detect potential malicious attacks. A special LCNT neural network is used to analyze the data. It can work with screenshots of the events and take info account provisions activity, which is very important for detect complex animals. LTM analyze how events are connected in time, which help you to find hidden patterns typical of software implant or botnet. This reduces the number of fails positive and increases detection accuracy. The experiments complex the effectivity of the possible methods with traditional method approach since the DESSERT tree and Biden classificator for the text steganography, CNN, H-white an equality for 99.2%, which is significantly higher than other method. For malware detection, LCMT models are reach 90.75% equalities. Such high result demonstrations the effectivity of the neural network in this are confirmed feasible of the use in cybersecurity in system. The results show the sensitivity and specific of the more exist 99%, which are excellent identification. This demonstration the system can accurately detect both steganography in image and bound software behavior. Such high effectivity is try combination of CNN and LCL capables, which complex each in analyze different types of the data. However, despite the successful, the system have limitation. One is suffice models need to be used to analyze image and system elements, which can insect the need for combination computer resource. This is especially important for system with limited capabilities. In addition, the effectivity of the models depends on the quality of the training data, so it's necessary to constant update and implement so the system can detect new type of threat. To overcome this limitation, first optimization for the system is important. In practical, the possible of combined CNN and LCTL function in one hyper model is be uh, uh, consented. This will reduce the amount of combinations, the important improve system performance. It is allow planets to apply models, compress and train transfer learning method, which will help reduce memory and CPU requirements. To verify the system effectiveness was tested in the real world task. Our simulation was models when attack used image with steganography to train commands to the botnet. The system successfully detects the steganography in the upload image and using activity of the relative process. This allows a use to quick block malicious attack. As a result of the study, the system for detection steganography control program implant was developed. Test the system was training and testing. Result of the testing system showed a high result. That's all. Thank you for your attention.
Thank you very much, Nutro, for your report. Who has questions, please? Go ahead, Barry.
Okay, thank you, Dmitro, for your presentation. Could you please give more details about your case study? For example, what database did you use to train your model? If it is a public data set, how do your results compare to other scientists' research?
Okay, thank you. We use two dataset in training my system. First dataset, we use open source image training CNN from detect steganography, and two dataset we using create one second. We create data set my team, not open source project, not open source data set.
So it was your own data set. It's not public data set.
No. This model is testing because he need update and optimization. This first result of this system.
Okay, so now I understand. So if it's your own data set, you can't compare with other studies because it's your own results. But do you think about to try to train your model on any public data set?
I think is future try public dataset for LDSM model. at training.
Okay, thank you.
Thank you. Who has additional question, please? Okay, no question. Thank you very much, Dmitro,
Thank you.
for your report. Thank you very much, Daria, for your question.